Hello, my name is Naidul Islam Siam. I am gonna be talking about the assignment that was given to us. It was a project to create an image object identification system on AWS. It is a serverless pipeline which is using YOLO v5, AWS Lambda, API Gateway, and Amazon S3. The problem and the goal of it is to the goal of the goal is to take an image, identify every object in it automatically, and store the results without managing any servers. We detected by running a YOLO v5, a pre-trained object detection model is that has 80 COCO classes, and we serve it by exposing it to a public HTTP API with API gateway, and we store it by saving the annotated image and a JSON of detections to S3. And the methodology or the system architecture is the how when the client posts a bucket plus key to the API gateway, which then triggers the AWS Lambda, and then the Lambda pulls the image from S3, runs the YOLO v5, it then draws boxes and writes on the annotated image and the JSON back to the S3. So that's basically how the system functions here. And moving forward, how one can request the flows. It would be to first upload an image. The image lands in the S3 inputs slash folder, and then the second would be to request the client posts bucket key to the API with an API key, and then it detects the lambda loads the image, runs the YOLO v5, draws boxes, and it stores annotated image plus detection JSON writes to the S3 outputs. And then it responds with the same detection summary returned to the HTTP response. The key idea here is that the request only carries a tiny bit of JSON, which is the bucket plus the key. The big image never travels through the API, it stays in the S3. This sidesteps the API gateway that of the 10 MB payload limit. Um, Moving forward, we have how we built it and how we deployed it. We had to containerize the whole thing because the YOLO v5 and the PyTorch, it exceeds the Lambda's 250 MB zip limit. So the function is packaged as a Docker image, and we built it on an EC2 as a temporary EC2 instance was purely to build the image. It's not part of the running system, and we had to push the image to the ECR. The built image was stored in a private ECR repository. Lambda deploys from that repository. And to wire it up, the Lambda gets a least privilege IAM role. The API gateway fronts it with an API key. And the output and the results of it is it works. We had 11 objects detected in the image, whereas it has marked all the possible objects, and there are 80 classes that are available, and 200 HTTP response were found. And then the output discussion, we have the performance and the cold starts. So we can see that the cold start evidence, the first start that we did, it took roughly 6.19 seconds to start. For the it loads the PyTorch and the model as well. So after that, the warm starts, which were the second, third requests, it all were processed under 1 second, that is 0.32 seconds, or roughly 0.33 seconds. And yeah, Then the key reflection that we had was container versus zip needed for the site, but it was what caused the cold start. The security issues that we had was the least privileged IAM. The one broad spot is the Wildcat CloudWatch, which logs resources, and the payload was passing the S3 key, not the image, which was keeping it under the API gateway's 10 MB limit. And if there is no lambda in it, we can reuse the same ECR on ECS Fargate for a no cold start, pay for the running task. And in conclusion, a fully working serverless detection pipeline was created. It was built and deployed end to end on AWS with an API gateway which was forwarded to the Lambda, which was using a YOLO v5, and it was then moved to the S3. We proved it live with 11 objects detected through the public API, and the results were stored in S3. We measured real behavior. Cold starts were 6 seconds and the warm starts with 0.3 seconds. So this concludes the creation of the serverless image detection and image annotation with AWS. Thank you for listening.